Hello everyone, welcome back. In this video, we are exploring closures in Swift. We will start with the basic closure, move into capturing values, and then dive into escaping closures. Using a practical example, we will also cover return cycles and how to prevent them with a weak references. So first, what is closure? Let's start with a simple example to introduce closure. A closure is a block of code you can store in a variable, pass around, and call later. Here we define closure named greet that takes parameter name of type string. Inside greet we have print statement that outputs hello and then the value of name. To execute this closure we call greet with argument shubham. Now let's run this code. As expected, we got Hello Shubham printed to the console. This shows how Closure can store and execute code. Now, let's look at capturing values with closures. In Swift, Closure can capture and retain variables from their environments. Here, how it works. We have a function here called makeIncrementer, which takes an integer parameter, increment amount. The function returns a closure of type this, meaning it takes no parameters and return an int. Inside make incrementer, we initialize the variable total, it's set to 0. Next, we create a closure name incrementer. These closures take total and increment it by increment amount, then return the uploaded total. Notice that the closure captures total and keep it around even after make incrementer finishes running. Finally, we return incrementer, which now acts as our incrementing function. When we call make incrementer with 5, it returns a closure that increments by 5. Let's print incrementer by 5 twice to see the captured value in action. Now we will run this code. As expected, we see 5 on the first call and 10 on the second call. This happens because total is retained within the closure, showing how closure can persist values across function calls. Now we are diving into escaping closures in Swift. Escaping closures are closures that outlives the function they are passed to. This is commonly seen when working with asynchronous operations like waiting for a timer or a network request to complete. We will use a simple timer example to understand escaping closures. Let's start by discussing what an escaping closure is. Normally, when you pass a closure to a function, the closure is executed and discarded once the function completes. But with an escaping closure, the closure can be stored and called later, even after the function has returned. This makes escaping closures perfect for situations like delayed tasks or callbacks from network requests. Now let's see this in action with a simple example. Here's a basic example of illustrate an escaping closure. First, we define a function called perform task with delay that takes one parameter, a closure named completion. Notice the escaping keyword in closures type. This means completion is an escaping closure, which allow it to execute after perform task with delay has finished running. Inside the function, we print task started to indicate that our task is underway. Next, we use dispatch queue.main.async after. To simulate a delay of 2 seconds after this delay, we can completion. Outside the function, we call perform task with delay, passing a closure that print task completed when it executes. Now let's run the code to see the output. As we see in output, task started prints immediately, indicating that the task has begun. Then after a 2-second delay, task completed is printed by our escaping closure. This demonstrates how the completion closure escapes the function and executes after a delay, even though the function itself has already written. So, escaping closures are helpful for asynchronous tasks like network requests or delayed actions. By marking the closure as escaping, We allow the closure to outlive the function it's passed to, which is essential for tasks that may take time to complete. Now let's discuss why escaping closures often need weak references to avoid return cycles. Return cycles can be a common issue with escaping closures, especially when they reference self in classes. Understanding return cycles. When we use escaping closures, especially in asynchronous tasks, these closures can hold a strong reference to any object they capture, including self. If self also hold a strong reference back to the closure, a return cycle occurs, where both self and the closure are keeping each other in memory, preventing either from being released. In such cases, the instance will remain in memory even after you would expect it to be released, which can lead to memory leaks. To summarize, closures are block of code that can store and execute later. Capturing values lets closure retain variable from their surrounding environments. Escaping closures allow closure to be called after function its passed to has returned, which is common in asynchronous tasks like timer or network request. To avoid return cycles in escaping closures, we use weak self in the capture list, ensuring memory management stays under control. Thank you for watching. If this helped you understand closures better, don't forget to like and subscribe. See you next time.